All right, we're going to get started. Hopefully you all had an exciting day, and hopefully these last sessions of the day will be just as exciting. My name is Tony Petrosian. I'm with the SQL organization at Microsoft, and I'm here with Lindsay Allen. Lindsay?
Hi, good afternoon, and my name is Lindsay Allen. I'm a co-worker with Tony, and we're all from SQL Server.
So at Microsoft now, we've pretty much combined all SQL assets under the database systems. So SQL DB, SQL Server, Azure SQL Data Warehouse, we just think of them all as just SQL. So we're going to talk about SQL stuff today. It universally applies to most SQL things. So we're not going to do too much distinction between SQL Server and Azure SQL DB because a lot of the things we're going to talk about in the SQL engine, and it's all the same. So just to quickly dive in, when we think about SQL, this is what we're talking about. So this is the products and services from Microsoft database systems. We have SQL Server, which we have generated a lot of excitement recently with SQL 16. We have SQL Server in Azure VMs, which is basically any version of SQL Server you want. You can go launch in an Azure VM and use it. Azure SQL Database is our PaaS offering. It's a fully managed cloud database service. We'll talk about that as well. We have our APS analytics system for on-prem data warehousing, big data, and we also now have Azure SQL Data Warehouse. And all of these products are being developed under this new model, which we call cloud-first approach, where all features are being developed in the cloud first. So when we want a new feature from our engineering organization, we go tell the engineers to go build it. They build it, they test it, they deploy it into the cloud first. We do our private previews and public previews, and ultimately that piece of code ends up in a build, which becomes a release candidate and ultimately a SQL Server product that gets shipped. This gives us a lot of agility because the cycles in the cloud is much shorter, and we don't have to wait 2, 3, 4 years for a product to ship before people have access to new features, where we get feedback from customers, tell us what is good, what is bad, what's missing. So those cycles are very short. So as an example, we just introduced RLS for SQL 16, which is row-level security. And that feature was basically developed in about 6 months, including a lot of previews with customers, real customers who are building applications, using that, providing feedback. You can incorporate the feedback, deploy it. And most of the services, actually all the services now, are being managed by the development organization, so we don't have an IT organization or an operations team anymore. So the developers who write the code are the ones who deploy the code to the services, and they're the ones who debug when things go wrong, and they're the ones who build and support the product. So when you have troubles with any of the Azure SQL services, when you call CSS, it gets escalated to the development organization straight. So this is how we build things. It's important to kind of know this is new. This is what we've done after we shipped SQL 14. And we basically have a single source base. Everything comes out of what we call the SQL main and DS main. So it's just one code base for Azure SQL Database and SQL Server. So let's look at a couple of things. So we'll just talk a little bit about Azure SQL Database and how we think about a service. Azure SQL Database is a cloud database service, which means we take care of all the administrative stuff. We manage the environment. We patch the operating system and the instances and so on. And you get to use a database. The database is a SQL 16 engine, which powers Azure SQL Database. And the way we think about the service is, okay, well, we got lots of good features in SQL, and you can use those, and database features are on all of our database products. But what we really are focusing on in a cloud service is the cloud and service aspects of this. What do we mean by that? In Azure SQL Database, we have a lot of features that learn and adapt, and we'll cover some of that. Being able to scale up and down, being able to efficiently use tens of thousands of databases, work in an environment which you're most comfortable with, if you want to write code in PHP or Java or whatever. And then the security is a huge concern for a lot of people, so we do a lot of investments. And so these tiles that you see here are the areas of focus for Azure SQL Database, but it also, in a lot of ways, it influences how we build the on-prem product, which customers end up using. So just to give you an idea of what we mean by learns and adapts. So we have this system, and we collect telemetry. All aspects of Azure SQL database is instrumented, so we have telemetry coming from all components, and we're able to look into what's going on with every database around the planet. We're able to detect every SQL error. We have a baseline for every SQL error that happens in the entire environment. And that gives us the ability to do anomaly detection. And what is an anomaly detection? Well, because we have telemetry on everything, we can see that a given customer application generates, say, 5,000 exceptions every day. Because, I don't know, they try to drop a table that doesn't exist, so SQL generates an exception. And we have a baseline for that. If you go in there and deploy a schema that has an error, and all of a sudden your exception rate goes from 5,000 to 5 million, that is an anomaly. And we have machine learning algorithms that detect that because we really want to get in front of issues like that. And you might get a notice from us saying, hey, we just noticed that, all of a sudden you went from having 5,000 exceptions a day to 5 million. Perhaps something is wrong with your schema. And this is what we mean by the anomaly detection. And we use this for security reasons. We use it for all kinds of administrative reasons. We also have the performance insight coming from the same thing, right? We see all of the resource consumption, the resource utilization, so we can give you this information about how your database is consuming resources so that you don't have to spend a lot of time figuring out what's going on, which query is consuming how much CPU and so on. It's all part of that system, and you have the access to the information. We have things like Index Advisor that tell you about missing indexes, because again, we can see what queries that are running. We have these algorithms that goes out and looks to see how you could optimize this workload, and you can build new indices that cuts down your CPU utilization or your IO utilization. And all of this generates actionable recommendations for you so that you can actually focus on building your application, and we'll focus on running the database for you. Now, when it comes to scale, we have different sized databases, and each database comes with a set of reserved resources, and you can go up and down. You can change the resource allocation of a database from very small to very large. All of this happens online, so we don't take the database down. We don't ask you to turn off your application for an upgrade or a downgrade. It just happens online, and we take care of it in the background. It's very handy. I don't know, we have some customers who go to bigger databases when they do administrative things, end of the week, end of the month. We have some customers that go to big databases in the morning and small databases in the evening when their workloads change. So this is the kind of stuff where you basically size it to what you need at the time you need it, and it's all online operations. We've recently introduced pools. The idea of pools is that you can buy a pool of resources where you have a bunch of databases in there. This is a really popular feature with our SaaS customers. One of our SaaS customers just tweeted a couple of days ago that they have 10,000 databases because they have 10,000 customers, and they're a financial institution. They provide accounting software. So all of their databases are in pools because it allows them to utilize the resources as efficiently as possible, but still maintain full control over individual databases. Resource governance per database, security administration per database, but not having to pay for resource reservation for every database. So this is very popular with all of the SaaS. So if you're building an application with lots of databases, pools are something for you to think about. We want to make sure that you can use the languages of your choice, work in the platform of your choice. So obviously, if you want to write code on Macs or Linux and Windows, we don't care. We're trying to enable all of those and languages of your choice, and we'll talk a little bit about that later. All of Azure SQL database features are accessible through the portal or PowerShell or REST APIs. So if you never want to go to the Azure portal, but you want to manage your databases, you can basically do that from APIs. And of course, it's just SQL, and all of the Visual Studio tools work with SQL, SQLDB. It's all the same. When it comes to security, we pay a lot of attention. Security is a hot topic, and we'll do some demos a little later about security, so I'm not going to spend too much time talking about this, but most of the security features that we build in the cloud also ends up in the box. Some of the features were motivated by our box customers that end up in the cloud. So we have a really nice group of users in different environments that are driving and motivating the changes we're making in the areas of security, both for on-prem and in the cloud. So just think about all of these things. This is what we think about at Azure SQL Database. And I spent very little talking about a database because Lindsay is going to talk about databases, and it's all the same. So when it comes to the service, it's about how easy is it for you to use 10,000 databases and write an application and not have to worry about managing 10,000 databases. So with that, I'm going to hand this to Lindsay. She's going to take us through some of the new things we've done in SQL Server, which is very exciting.
Yeah, thanks, Tony. And yeah, security is the hot topic. I just flew in last night from DC, and we had customer events there. With the customer in that area, security is the leading topic. Sometimes it's the only topic. So what's new in 2016? And it's a tough thing to say because it depends on what you're using. So can I have a show of hands? How many of you used 2014? Oh, quite a bit.
Wow.
Okay.
Excellent.
That's impressive. Okay. So since I actually don't know my audience, how many people used which version, and we have so many new features and capabilities in SQL Server 2016. So I thought since we only really have like 20, 30 minutes to talk about new features, right? I'm going to pick some highlight. And in 2016, we actually published a lot of Channel 9 videos with drill downs, like the new column store, in-memory OLTP, R integration services. We actually have a whole session on machine learning if you're interested in R. So SQL Server 2016 really is way, way more than a database server. And it is actually a data platform, mission-critical data platform, end-to-end. It's including an operational relational database management system, and which is where SQL Server started 27 years ago, and actually have a business intelligence, SSAS, analysis services, reporting services, integration services, and we're the #1 scale-up data warehouse. If you go look at the TPCH single node, top 3 a SQL Server. And we added the new workload, right, with our RevR acquisition. So now actually we have the built-in. You can actually download our packages to run inside the SQL Server. So you can have a machine learning workload to run right inside the SQL Server.
And this is really, really important to a lot of customers who want to build intelligent apps that do predictive models or fraud detection. And having to take the transactional data out of the database so you can run predictive scripts on it is kind of a problem for a lot of people who have to comply with various regulation. So bringing R into the SQL engine enables you to basically do the analysis where the data is, not have to move the data out of the database.
Yeah, time is money, right? For example, one of our case study customer, MasterCard, and lots of these credit card fraud detection are analytics queries, right? You have to do aggregation, scan, and aggregation. And if you run the model on the data, they don't want to impact, normally you don't want to impact your transactional workload. You move data in another server and do your analytics. And the challenge is there's a delay and fraud and going to cost the business money. So the sooner you can detect the fraud, the least money you're going to lose, right, with all the security concerns in the world these days. So if you can run these analytics queries right on top of your transactional database, it's real time. You'll save lots of money. And we actually enabled, one thing we enabled is column store, which is for analytics query, and right on top of the transactional row store. And they are integrated within the same engine, but a different storage engine. So the query optimizer will know if you run analytical query, well, actually it's not going to use your row store or try to use the column store. So they don't actually interfering with each other as far as the data page reading concerns, right? So you can have your real-time analytics in the same database with SQL Server 2016.
Leveraging in-memory technologies both for OLTP and column store removes a lot of the I/O related stuff, and being able to run both workloads concurrently on the same engine That's gold.
Yeah, and this is all available in SQL Azure. So today, you don't have to wait for SQL 2016 to be released. Just go to SQL Azure and create a database. This is all available. We deploy it to SQL Azure every month in production. It is available both on-premise and in the cloud, pretty much all the features. So sometimes we have so many features without not actually writing blog or announce them anymore. But today, we actually deployed JSON. So we have JSON support in SQL Server. So as of today, our deployment in production in SQL Azure finished. So it's in public preview.
Yep.
And of course, we have we made 2 major acquisitions. One's called DataZen, and now is last April, DataZen and Revolution Analytics. They both integrated with SQL Server 2016, and they will be available. Right now, it's in preview.
Yeah, so if you thought that SSRS was starting to look dated, you should check out the SSRS in 2016. It's awesome. It includes all the mobile BI capabilities and the ability to publish to mobile devices of your choice, Android, iPhone.
iOS, any HTML5 enabled device. It works everywhere, and it resizes itself, right?
Yeah.
It's actually the visualization fits the form factors. Yeah. So instead, I have a list. So I thought I'm not going to go through this. I didn't want to scare people, but since we have a lot of capabilities component in the box, I thought I'd just give you a visual and what's actually in SQL Server, right? There's engine, there's BI, and there's data integration, which normally lots of folks actually buy MicroStrategy or Informatica actually just to move data around, right? And there's this very scalable, high-performance data warehouse, and we integrate with beyond relational Hadoop as well. So let me just go through the 3 Ps fairly quickly, and only call out, what's new, right? On the engine part, with #1 performance, because now we're the only one actually publishing transactional workload benchmark and the data warehouse workload benchmark. We still have
same
one
engine.
in the same engine. And I normally would do the demo on the scale up on the new HP Superdome with 480 processors. We scale really well. If you can have a bigger box, we'll use it all. We can scale out. We also can scale out with our appliance. And we have in-memory, both in-memory, the row store and the column store in the same engine. So we're the best at run the hybrid workload. What hybrid HTAB? I put it up there, HTAB. Gartner got this new term called HTAB, hybrid transactional analytical processing. So that's actually what the real world is, right? People doesn't really actually have transactional and data warehouse in the separate 2 engines, because they have to do it that way just for performance reason. Now you can actually put them all together, hyperscale to the cloud with a stretch database. So if you're 10 terabytes database or 50 terabyte database, 50% of them are fairly cold, and you can't really delete them in case you still need them, right? And we can actually stretch those out to SQL Azure. Still online, you still can query them.
And the database engine knows when it needs to go to the cloud and execute remote queries against that remote data, bring it back, and compile the results and give you the answer, even though you're touching data which is not even in that particular instance of SQL anymore. So this is all the distributed query processing capabilities in SQL, and it basically does it for you, and you don't have to worry about where is the data. You don't have to go and load data from tapes when the auditor shows up and wants to see data from 5 years ago.
Right. Lots of investment in security. Tony can talk about it later. And I do want to call out, we actually work really hard to make sure we utilize the new modern hardware, right? One thing we actually we utilize with transparent data encryption is the APIs, already security APIs, already Intel chips.
Yep.
The AES and NI API. So now we use only 1/10 of the CPU cycle when you use transparent data encryption. You will see performance overhead way less.
Yeah. So if you use TDE in today's SQL Server 2014 or earlier, when you switch to 16, we're able to use the hardware capabilities that comes in the Intel chips, and all of a sudden your CPU utilization goes down.
Yes. And then another innovation in Intel processor is the vector instruction set, or SIMD. And we utilize it to actually do push-down computation for the column store aggregations. So for lots of aggregation, if the push-down actually happened to the processor, you will see actually data page does not actually go all read back in memory doing the aggregation. The performance for that particular query, if the push-down happens, could be 100 times faster. And with HA, we actually utilize lots of features. We actually learned our experience, right? We learned from Azure, and we actually deployed them now, make them available in SQL Server. For example, the cascading availability group.
Yep.
So we allow 8 secondaries. If that's not enough, you have plenty of data centers, right? You can create cascading secondaries. So you can have 8, then you can have another 8.
Yeah. When you run millions of databases that are replicated in the cloud, you do learn a lot of things. And so those learnings do come back in the code base, which ends up in SQL Server. We also have a much, much faster replication for always on. So if you run primary and secondary machines and you're replicating, I don't think you can push enough transactions for the replicas to fall behind. I mean, we've done a tremendous amount of work to optimize replication between primaries and secondaries. With compression and other algorithms. So it's much, much faster again.
Yeah, thank you. And so these are integration services. Actually, it's the most popular feature in SQL Server for the longest time because number one thing people have to do is move data into SQL Server. So integration services is included as it's very convenient to have a design canvas and have debugging surface, and you can execute your packages, managing the package. We did lots of investment in 2016 to modernize the enterprise manageability. Data quality services and master data service, both was V1 product in past couple of releases, and we made a lot of improvement in terms of performance and capabilities as well. Then the BI, or the BI or advanced analytics, what I want to call out is we actually did not forget analysis services. Last week, I have plenty of customers says, you forgot about analysis services and the tabular and the MOLAB. We didn't. We actually did lots of improvement in the enterprise BI server. And tabular and MOLAB both are improved. And Tabular now supports many-to-many and can do parallel partition processing. Reporting services, we made acquisition. Now we have the data zone integrated. Our service, that's another one, and it's a new capability. And we actually expose Polybase now inside the SQL Server. So you can run T-SQL queries through external table pointing to Hadoop.
How many of you have Hadoop systems?
Like real Hadoop systems. Not that many.
Oh, not that many. Well, you should try them. So a lot of our customers
don't try them if you don't have them.
Yeah. A lot of our customers who collect telemetry from devices, IoT apps, they do use Hadoop. And what happens is that you have this vast amount of data sitting in Hadoop, but at some point, that data needs to be correlated with transactional data. For example, we have a customer, they're an insurance company, they collect telemetry from vehicles about driving habits. But the customer data, the policyholder data is in a database. So they can use Polybase now to actually run queries against the Hadoop data, which is the telemetry about driving habits, and join that data with data in SQL, which is customer information, and produce the results, which basically says who gets a discount and who doesn't. And not having to move the customer data out of SQL into Hadoop and not having to take all the Hadoop data and putting in SQL is a huge advantage. So with Polybase, basically, you can reach out of SQL and go run queries against Hadoop, and we do the pushdowns, and we get the data back, and you get a single result, even though the data is in two completely different systems.
Right. We support Cloudera and Hortonworks, a couple of versions, and the blob store in SQL, in Azure blob store. So we did tons of investment in terms of performance tuning, paying our debt. For example, spatial, our spatial data type originally was completely implemented in CLR. We actually spent a lot of engineering resources to make those lots of the functions native. So some of the spatial, you'll see the spatial query actual performance improvement like 1,000 times. And these are some of our partners actually been working with us on SQL Server 2016 for a while now. Pros is ISV, they're doing online sales or pricing analytical service. Basically, if you're airline, 75% airline, I think, using them. If you go buy an airline ticket from point A to point B, depends on which route you're taking, the price is different because they have these algorithms running and predicting based on different features, the popularity or what have you, right, on the price. And the KPMG, they got a 1,000% performance improvement is because now they don't have to move data around anymore. They put the model directly inside the SQL Server. With KPMG, there's their auditing application. They changed from row store to column store, and they see 2.5 times performance improvement, and the compression reduced the size to 1/10. And another global ERP system remain unnamed, and upgrade to 2016 is 700% faster. Tableau, one of the #1 BI vendors, and their worksheets moves, if you upgrade underlying SQL Server from 2014 to 2016, I see 119% improvement. So move along, I think we're going to be running out of time. Non-volatile memory, I just want to mention, we're working we keep up, we try to really keep up with the hardware trend. What a non-volatile memory is, they're the SSDs and actually on the memory bus. So they're cheaper than your dynamic RAM, and it's faster than NAND SSDs because they're not on the I/O bus. And what is SQL today is normally you'll see is because I/O, right? The performance impact is because I/O is too slow. And what a non-volatile memory can do is to help you transaction performance by reducing I/O latency. And there's two ways you can just use as a block device. With Windows Server SCM storage class memory support as a block device, just don't need to do anything with your application, and you're just going to have super fast I/O, still going through I/O paths. But not actually, this way of using the non-volatile memory is not to maximize the potential, right? So there's another way to use it. Since they're really actually on the memory bus, and now think about it, your data in memory does not actually need to be flushed out anymore. You don't actually need to do I/O anymore because it won't disappear if your machine loses power. And so direct access will allow you application to allocate memory and use the memory mapped files with the Windows API, which is already available, and write your data in memory, and it will stay there. And you will have a really fast performance. What we enabled with the SQL Server 2016 is for tail the log. Tail your transaction log to be in the non-volatile memory in direct access mode. So that's the sum of the test data you see.
If you have extreme OLTP needs, where we are pushing tremendous number of transactions and you have extreme degrees of concurrency,
yes.
This is how you achieve transaction rates never seen before.
Right. So I think we're long overdue for demo.
So we're going to show some code?
Yes. So I thought, a couple of features really need developers to write code, right? So I thought we're going to demo those. One's in-memory OLTP. So you can create your table object and your store procedure as a memory object or native compiled will give you a lot more tremendous performance. You can see up to 30 times. With that, I'm going to show you the demo. This both works in SQL Azure and Azure DB, right? Yeah. And also in so that's my handle in Twitter. I used to be in SQL Cat. I used to manage cat team. That's why I had the handle herd cats. So I'm going to start in the Azure portal. And since for developers, so when you create a project with your teams, right, you need a source control. We enable the source control through GitHub as well. So I'm not going to go through create a new one for the time. So we already have a project created for this particular demo. I can open it directly from the portal in Visual Studio. I've been trying, so open multiples. So this is actually a simple app. I have, there's two projects in the solution. There's a workload app, basically just doing lots of insert. It's the ticketing app.
Okay.
So it's a simulating if you have to go buy tickets, right? And for some online show. And for these, you want actually they run really fast. Otherwise, you'll lose sales. So there's lateral load generation, the database project itself, and is where actually will create your database and create a table for you. So let me do this. I will do a quick rebuild, just make sure that everything still works. Okay. Then what I do is, let me show you. It's fairly simple table, and I have ID, have a detailed ID, then quantities, how many you're going to buy, and some random comment field, right? And this is a traditional table, and I have a primary clustered index on this table. So let me push this out just to, all from here is can actually create this table in my, there, can't even see. I'm just going to push this out to my local server because it's I know it will save time. Okay, it's out, it's done, they're pretty fast. Okay, so now let me run this little app. So we have a baseline, right? So now is doing, if you look at the configuration, it's basically doing batches of 20 rows insert to this table. And of course have other metadata to go with it, right? It's doing about 1,000 insert batches a second. And that's on my little VMs here. So let me stop this, see what we can do. Simple thing for here, if all you really need to do, if you want to change this, say this, I know this is my key table. If I put this all in memory, and it will save a lot of transaction latency, right? All you really need to do is, whoops, see, I know, kind of type in front of people. So if you add with memory optimized equal to on, and this table, SQL Server will create it as memory optimized in-memory OLTP table in the same database. And same thing you could do is if you add, you can add the memory optimized here. Let me stop typing here. I'm just going to switch out of this. I have one typed already to show you.
So and all
Maybe
of this
faster.
runs with TFS, continuous integration with SSDT. You can also put it in GitHub if you want. So SSDT, we've done a lot of work for the developer tools for SQL and Visual Studio.
Yep. So with, if you can actually not compile the native compiled store procedure, you can leave regular store procedure, just create the memory optimized table, or you can actually compile both, right?
So when you compile the stored procedure, basically you go from interpreted T-SQL to machine code.
Machine code.
And
through
so
a C
your
compiler.
written stored procedures will run as machine code.
Right. So let me delete everything in there. I inserted first. Okay. So I'm going to publish this out to the same place. Okay, connection still good. Okay, it's done. Let's go back to this little app. See?
Yeah.
Thank you.
A lot of good things happens when you don't have to pay the disk tax and the I/O path. And in in-memory OLTP, it's not just about not doing I/O. It's not like, okay, all the data is cached in memory, but it's actually eliminating a lot of the I/O path, code path. So it's a lot less code, and it's in memory, and you're avoiding going to disk, right? So that gives you a lot of throughput.
Yeah, right. And so as Tony mentioned, this is all integrated, right, with Visual Studio Online. And so if I go make some changes, if I remember to commit, and it can continuously publish to my production environment. And I hope this is all going to work. Change something. And if I do commit and sync, it should sync directly to the through Visual Studio team projects through GitHub, and other my team members should see my change. And if I go to, oh no, I don't need to go there. I'll go back here. There we go. So from here, I can Team Explorer. Where did my portal go? Home. So you see, I just synced, right? So if I go to Visual Studio Online, and here's my project in the build page, and you can see maybe this is already done. Yeah, you can see just now, I just did a commit, checked in a change, right? So I just did a checked in a change, and if I want to go there to see what's happening, and it's being deployed to UAT, and after the UAT environment deployment finished, I can actually go to, when this starts, I can go approve it to deploy to production. And all this can happen within the same environment and continuously. It's very convenient. If I change a code, I can go deploy it right away. And another interesting features, I think, for developer is something called temporal data support. So you know, if today you want to track your data change, and you actually have to create a schema, and you have to change the query extensively, know which table and which field, right? It's getting really complicated. And now we can actually track those system times for you and automatically. So all you need to do is mark that table as temporal. And we'll be able to track this, integrate it with the query optimizer, and by default, you have the current date. And if you current data, if you actually add a predicate as of a past date, and will return a snapshot of a date as whatever time you specified.
So if the HR VP comes to you and says, what is our salary liability as of right now? You can do a sum on all the salaries you pay and say, okay, well, we pay $1 million a month in salaries. And go, well, what did it look like 6 months ago? Well, in order for you to answer that, you either have tracked all of the changes over time, and then you have some complicated code that reconstructs what the things looked like, or you have saved all of your reports from 6 months ago, and you can show up with a printout that says, okay, this is what it was 6 months ago. Or if you're using temporal and those tables have been marked, you can just basically time travel. You say, what did this look like 6 months ago? And the database will answer as if you ran that query 6 months ago on the data, whatever it was there 6 months ago.
Right. And so it's really simple. And you create your table. And if you actually want it to be temporal supported, you can actually add the start and end time. You can store that as row or store that as column store as well. If you want to store that in columnar store, it will compress better. And when you query it, you just need add, that's a new predicate, right? You want to query the history data and add the system time as of a past date. So let me show you.
We get excited about time travel.
Yeah, and now my UAT deployment finished. I just want to show you here, simple, easy, and you go click on your package, and it's just, look, it's waiting for me to approve the deploy to production. Since I know I did not change anything really much, so I'm going to deploy it to production. So it's very straightforward. Let me show you the time travel demo. I have a little app and showing, you know, the org chart of our European engineering team back in, as of today, right, 2016. And so if I say, you know, back in 2014, January, what does it look like? I want to see January 1st. It was a lot smaller. We just started in Belgrade at that time. We have human resources and some production support. And if I want to see, let's compare back in January 2014 and today, and what's the difference? See, we got 6 new branches, and this is today and January. And this looks interesting, right? See, it's actually not that much work to get this done. Really, only thing we did is, it's a typical ADO.NET app, right? Connect to a view. We didn't actually create anything complicated. On the SQL Server side, you just need to create a view. So I have company, location, and department. And what's different is we're going to track time change for you. And this is today. If I run this query, that show everything you see in this Lighto. Where did my Lighto app go? Here, you see everything here, right? And if you go, oh, why the resolution look like that? Okay. If you go back to, I want to look at what the 2014 January looked like. I ran the same query against the same view. It's just like passing a parameter. This shows, as of 2014. If I run the comparison between 2014 and today of the same org chart, you can see there's 8 rows, right? The difference. That's what actually shows up in the Lighto app. The green actually showing the new ones. So we did a time travel is really easily.
Yeah. So if you had to build this in your own code, obviously you could, but it'd be really, really difficult. So the whole idea here is we're trying to make it easier and easier for people to write really, really intelligent apps without having to make you do crazy amount of coding, right? And this is an example of that.
Yeah, with that, I'll hand it back to Tony to talk about security.
All right. I lost my glasses, so I had to buy this at the bookstore. They have a horrible glare. So one of the things we've introduced in in SQL 16 is this thing called always encrypted. And always encrypted, the way it works is, there's some sensitive data that you really want to encrypt. But if you were to encrypt sensitive data, you have to make changes in your app to have to deal with encrypted data. And that's not an easy task, and that's why people don't do it, right? Now, with always encrypted, what we've done is we've enabled our client drivers to basically do all of that heavy lifting for you. So if you have sensitive data in the database and you don't want the DBAs or people who have access to the database to see that data, but the applications still need to see the data decrypted, you can use always encrypted. So in this case, it's we've encrypted social security numbers, and what happens when you write a regular query and the application doesn't need to know anything about the fact that the data is encrypted, as the query goes through the client drivers, it could be ADO.NET or JDBC or whatever, the driver will actually encrypt the predicates before it sends it to the database. So then you can have queryable encryption. So you can do equality joins of encrypted data. And as the data comes back from the database, it gets decrypted by the client drivers, and you see the clear text. So it's kind of transparent to the application. An application doesn't really know that this thing is happening, so you don't have to change your code for it. And the drivers do this. And the security aspect of it comes from the fact that the keys that are used for encryption are now maintained and managed outside of the database, so the database can't actually decrypt it. If somebody breaks into the database and do a select on that table, all they see is encrypted data. The fact that the client application can decrypt it is because the client application has access to either an HSM or Azure Key Vault or a certificate on the machine which is running the client app that can actually decrypt the encryption keys, use the keys to decrypt the data, and your application gets to see that. So this is one of the examples of, again, trying to make it easy for you to write secure applications. So I'm going to run through a few of these new things, and we'll get to the encryption at rest. But I'll start with this app. It's a very simple app. It has a table. It's a ASP application. It's just running on my machine here. I've got a website. And the website goes and queries data from the database. Let's say it's patient information. And I have a user here, Rachel, is logged in. So there's a context of the Rachel's user information. And when Rachel looks at the patient, it gets all of the patient information. Now, what if Rachel wasn't supposed to see all the patient information? What if Rachel is working in a psychiatric ward, and she should only see data for psychiatric patients? Or maybe she works at the pediatric ward, and she should only see the patients that are assigned to her, and not other patients that belong to other doctors. So how would you deal with this? Well, you can write a lot of code for this to filter stuff or add predicates and say, well, if user is this, do this and that. The problem with that is every time you change the app, you have to deal with that. And if you write 10 different applications, you have to, again, all applications have to have that code. And when permissions change, policies change, security policies change, you have to go change your application. So what we want to do is enable you to do this without actually making you change your application. So I'm going to go here and show you some code. So I have a database. The database is actually in Azure SQL DB. It's called Clinic. And this is the database that has all this information in there. And one of the tables in this database is called patients. In this code here, I'm going to create a schema called security, because I like my security officer to be able to create security functions and security procedures in a separate place with a separate set of permissions. So I create a schema called security, and I can go create a security function, which basically is an arbitrary query that you can write, which will inject a predicate, which is associated and binds it to the table which you want to secure. So in this case, it's really simple. I'm saying if the context of this user, Rachel, matches the patients that are assigned to Rachel, then return 1, as in Rachel should see that particular row. Or if the user is a member of the DBA, is a DB owner, or if the username is TP, happens to be me, and the patient ID is less than 5, then I should be able to see those records, right? So I'm just going to go create this function. Execute that. So now I have that function. I'm going to go say, you know what? I want to apply that function to these tables, patients and visits. So now that's done. I go back to this application, and I'm going to rerun. And here it is. So only 3 rows show up. Now, you can go and change this function and adjust it. And this function is something that a security officer would do based on the policies at wherever they happen to be working. And you could use groups, roles, any of the other identity management systems to actually do this work. So you could simply add people and remove people from user groups or roles, and all of a sudden they will have restricted access to the rows. So this is an easy way of limiting access based on function and role. Now, another thing you would see here is maybe Rachel shouldn't really see the street address for the patients. And maybe that's something that should be masked. Well, it's easy to mask data. Every time you get a string, you can replace a bunch of stuff with X's. Again, if you want to mask data like credit card receipt, they don't print the credit card number, right? Well, if you want to do that in your application, then you have to do it for all the applications that access that data. And you have to have that policy, again, as part of your application. When the policies change, you have to make changes to the application. So in SQL 16, we've introduced a thing called dynamic data masking. And I'm going to show you about dynamic data masking on Azure SQL DB, actually for this database, Clinic database. As part of the properties, there's a tab here called dynamic data masking. We even make some recommendations for you. It says, hey, maybe that's PII. Maybe you should mask that data. You can actually use the portal to create masking functions. So I can go here and say, on the patients table, street address should be masked. And if I just click on mask, it'll actually do it for me. Or I can go and add arbitrary masking functions to rows, to tables, based on whatever function that I want. So in this case, I'm just going to take this recommendation. I'm just going to say add mask and save.
See, this way you can actually mask in the data and the application won't break.
That's right. So I'm going to go back to this website. As far as the website is concerned, address is a string, right? So now I'm getting a string, but it's just a bunch of X's. Now, for SQL diehards, that, portals and that stuff looks, different. So we'll actually go and look at it in T-SQL. This is the T-SQL function. Alter table, patient, alter column, last name, add mask. And in this case, let's go mask the last name. And I'm going to leave one character plain, put a bunch of X's, and 0 characters to follow. So you can have the leading characters, middle, last, right? So let's just run that. I'm going to go back to this app. OK, so the last name has been masked now. So you just see the first letter of the last name followed by a bunch of X's. So that's basically dynamic data masking. You can apply it. You can come up with your own function. You can apply it to anything you want. And it's really easy to get rid of, right? Because it's just a bunch of functions. Again, this is a set of things that you would have your security officer says, you know what? If you belong to this particular user group, you should be able to see unmasked data. Otherwise, the data is masked. And all applications, it applies to all applications because it is enforced by the database. It is enforced by the SQL engine. Now, one last thing we should do here. So the social security number shows up in plain text here. But, usually the healthcare workers know your social security number because you just gave it to them because they have to look you up and for your insurance, this, that, and the other. But you don't want anyone who manages data, again, let's pick on the DBAs, they maybe shouldn't see the data. So if I go and run this query here, I see the plain text. Maybe I shouldn't see the plain text because why would I need to see the social security numbers for a bunch of patients in the database? So let's see what it takes to encrypt that data.
It's always encrypted.
Yes, it's always encrypted. I'm going to go to the patients table, and we'll see if all this stuff works here. So there's an encrypt column, next, social security, choose an encryption type. I'm going to choose deterministic. Deterministic encryption ensures that I can do equality joins. You can also do random, which means basically the database will never be able to do anything with the data. You have to have it on the application side. There's an encryption key that I'm going to use. I'm going to use the certificates in the Windows Store. Because this is Azure, you could put it in Azure Key Vault. If this was an on-prem SQL Server, an HSM option would show up for hardware security, right? So I'm just going to say next, and just go ahead and do it. And what this will do is it'll go and encrypt that data, throw away the key. And from that point on, the database can't do anything with that data. Like the database itself can no longer decrypt it. Because I'm running the SQL Server Management Studio and that particular wizard on my machine, on this laptop right here, it actually took the certificate and stuffed it in my secret store. So my machine, which is running the app, should be able to see the unencrypted data because as the data is returned to this machine, which is running the web service, it can decrypt it. So let's go look at it.
Yeah, because your machine is both a server and a client.
Mm-hmm.
Yeah, so the client application actually has the key actually doing the encryption and the decryption.
Yeah.
So even it's on the same machine, it's doing a round trip. It's
Right.
going from server to the client and back to the server.
Now, if I click refresh, this thing is going to crash, so don't panic, right? Because the app just got a bunch of encrypted garbage, and the app was expecting a string. So what do we have to do to this application to actually make this work? Well, I'm going to go to my web config. There's this setting here called column encryption settings disabled. I will enable it and save it. and go back here, and hopefully it'll work.
By
if
the way,
you're
this
lucky.
works with the analysis services as well. As a data connection as source in AS, you can set that property with ADO.NET connection string
Right.
with AS. That will work as well.
Now, application sees the Social Security here, but if I go back to SSMS and execute, oops, I'm logged in as a user which has no privileges, so you'll see that the Social Security number is now encrypted. And so the database no longer can see the clear text, but the application can. So this is a really easy
Go
way.
back to the application?
Yeah. And there's the application. And it's not crashing because it can actually now get it, right?
Perfect.
So there we have it. I'm going to take a 30-second detour and show you something very interesting. In Azure SQL database, we have this thing called threat detection. In my databases, I enable threat detection and auditing for my databases in Azure. So I have this database, and in this database, we have auditing function and threat detection function, and it's enabled. And if threats are detected against my database, I'll get notified. We'll let that thing run for a second. So I have this application. It's called My Bad Website. And it's a really bad application because it doesn't check input. So it's a target for SQL injections. So I'm going to do a SQL injection to this app where 1 equals 1, comment, password, doesn't matter, and run it and see what happens. If it was a good application, you would say that's not a valid user. If it's a bad application, it will take that string and put it in a query against the database. I don't know if it's going to work or not. It's not looking good, Lindsay. All right, so this is the auditing. So you can see auditing is turned on, and threat detection is turned on, and notifications go to Tony. It did work, actually. So instead of saying that this is an invalid user, I actually got the results, which is really bad. And so we monitor databases, and we try to detect things like this and inform you. So if I go to my email, I should have an email that says something about potential SQL injection. So I should get an email. There it is. And it tells me that there was a SQL injection at this time, and it gives me the ability to go and look at the audit logs, right? And it'll show me the actual query and my own code that ran against the database that caused the SQL injection. Now, how do we do this? Because we're continuously collecting auditing data, we actually look for malicious stuff. And SQL injections are reasonably well-known patterns for us, so we can actually detect them. So in this case, here you can see that it was a select start from SQLi users where username equals, and this is the thing which I injected, and I commented out the rest of the query. So this is threat detection in Azure SQL DB. Okay, I want to finish with just a couple of things. We did promise that we'll show you some client stuff. So with SQL Server, you can use PHP, you can use Node.js, you can use JavaScript, you can use Java, you can use C#, you can use C, C++. We're working to enable all of these things on Macs and Linux and Windows, so you can write code from wherever you want, in whatever language you want, and run it against SQL. So here I have a Linux machine. It's running some version of Ubuntu. I'm going to go, and I have a Python script here, which goes against that clinic database. It's just going to do a select top 20 from that patient's data. And so, see, I get the mask data, right? And I got with
So the
row
engine
level
feature
security.
works against any kind of client.
Yeah, and if I
Regardless
go,
where you collect from.
Yeah, and if I go back to, I don't know, SSMS, and if I drop this dynamic data masking stuff, right? So things aren't masked anymore, and I go back here and mask is gone.
I got clear text.
And so this is from Python. Let's do a quick one from Ruby. So there's a Ruby version of it. If I go and drop all of the row-level security stuff, then you'll see all the data. Last but not least, let's do a Node.js one. And here it is. So basically,
now you can write your application in any language.
And if you have any trouble with any of this, send me an email. If you think that you're using a third-party or open source driver and it's not working for you, send me an email and we'll make it work. We work with folks who write TDS to make sure TDS works with SQL, free TDS, all the PYMS SQL for Python, Ruby, Tiny TDS. We work with the open source community to make sure that the stuff works against SQL. And of course, recently we said something about SQL Server running on Linux, so that makes things a lot easier. So that's a little bit of a news. Yep. So this is what we have for SQL. So maybe we'll take a couple of questions.
Yeah, there's Mike. The time is up, so we'll be around.
So Mike.
Thank you.
Hi. First of all, excellent piece of work, really.
Thanks.
One question. If you restore the database to another machine, will the encryption need to have some certificates so that means?
No, the data moves with the database encrypted and keys are separate, so the application would then be able to decrypt it.
So it's self-contained. I mean,
yes.
if I restore the database on a different machine, no matter what, still?
Correct.
Okay.
Yeah, we have an encrypted version of that key for redistribution.
Okay.
Yeah.
The second question, there are a lot of applications that they don't do different connection with a different SQL user.
You need to tell them field evaluation.
Yes.
Yes, which means that the context through which the row-level security could have been achieved is not that easy. Suppose that for connection pooling purposes, all of the connections are made through a specific user. Do you provide any other means in terms of the connection context so that we can differentiate the row-level security?
Yeah, you can use different context and different mechanism because it's an arbitrary query that you write for row-level security.
It should be fast,
yes.
however, because
yes.
it is executed in memory, right?
Yes.
Thank you very much.
Sure.
Thank you. By the way, remember to fill evaluation. I
yes.
just realized we're out of time. Thank you.
Yes.
So when you're encrypting a field, can you still do a query, or is doing a table
yes,
scan?
you can do equality joins, absolutely. Otherwise, it would be very slow. So equality joins work.
We maintain statistics on that column, and because we actually know it's not a simple blob, so you still can do seek or nested loop join, whatever. It's now going to be scanned.
And you can build indices on it.
And for the time machine, is it doing on the table or on the record? Can I?
On the table.
Table.
So the table. So I cannot ask if this record has changed.
You can ask the record changed, but you turn the whole table as temporal. So when you query per record. When you enable it, you enable the whole table.
You can write a query that says, show me what this row looked like 6 months ago. That would be the information about that row.
Okay, thank you.
Sure.
JSON data types?
Yep.
Yes. So we support JSON as functions that allow you to go from row to JSON, JSON to row, validate JSON, and process JSON. We don't have native JSON, so the data is stored as var binary.
Because there's no need to, right? JSON is just a text, right? And instead of go create another native data type like what we did with XML, this is way more efficient. And JSON will be validated, and you'll be queried, and you can add the computed column indexes on the JSON tag.
Right.
We can promote.
There's a great
demo.
a session on channel 9 just on JSON. So all the various JSON functions and how you can use them. So search JSON 2016 SQL, you'll find it. Channel 9.
Yeah.
Okay. With the encrypted column, how about the query rather than equality? Like greater, smaller?
No.
We're working on that.
Yeah.
So
Not
you
right
don't
now.
work on it?
Not in 2016, but we're working on that,
Yeah.
yes.
So right now it's just equality. It's really meant for things which you don't do calculations on. Like nobody does credit card number +7 or social security number -9. Those are just random strings. So for those pieces of data that are really, really sensitive that need to be secured, this thing works really well.
Right.
And then we also have transparent data encryption for if you want to encrypt everything, which at rest.
Yeah, okay, thank you.
Yes?
Hey, a couple of questions. One, can you combine temporal data with row-level security?
Yes.
Yeah.
Based on dates,
Yes.
basically?
Yeah.
Yep.
Yes.
The other one, that row-level security, there's a UI for it. I imagine you're just picking users and or groups and then providing conditions that these are the things they are or are not allowed to see?
Yes.
Okay.
And you don't have to use users, or you could write your own function.
Yeah.
Okay, thank
Yes.
you.
Yeah, with Time Machine, can I get a list of all the changes that happened, say, over the past month, so I could see like rows with each of the different states of each of the row with timestamps?
Right, you have to write your query differently? Yes, you could. So on predicate, then you need to actually create a subquery, so create as of whatever in between. Yeah. The
Okay.
query will be a little more complicated, right? Yeah.
One last simple question. The JSON support, is that in the SQL Azure right now?
Yes.
Yes.
It is?
Yes.
Cool, thank you.
Deploy today, you can go use it now.
Okay.
Yeah.
Same question for temporal. Do you maintain the full copy of rows or like differential copies of the rows?
Right now, we maintain the full copy of the rows. It's in an internal table. It's not together with your table. Yeah.
Okay, and
But you can store that in column store. It'll be compressed. Yeah.
okay. The other question, you have to specify as of on each table. If you are doing a multiple join, can you just say for the whole join, I want to have it at that as of date?
Yeah, you don't need it for each table, right? But for that whole query, for the query, but I need it before order by, before the aggregation. Yeah. Yeah.
Yes.
We have documentation online. You can look at the syntax. Yeah.
For temporal tables, if you change the schema or change indexes, does the old version have the old stuff, or is it just blow away the? What happens with that? What's
For
being changed?
now, it's locked. If you enable temporal, we are not allowed you to change schema at this version. Yeah.
Okay, thanks.
The in-memory optimizations that you guys showed,
Yep.
you made two tweaks.
Yep.
One is you made a tweak to the table.
Yep.
The second one, you made a tweak to the proc.
Yep.
Is there a world where you can have the mix, where the table is optimized for memory and the proc is not?
Absolutely.
Yeah.
Yeah. You can
And
do.
what does the performance increase look like in that? Like if you ran your little speedometer?
Right, so the result, so one thing, the native compiled procedure only work against the in-memory tables. You cannot have native compiled against disk-based tables, not yet anyway.
Got it.
And but you can create only in-memory tables without compiled store procedures.
Okay.
And that will work. And it's a performance improvement, it really depends, it's application, right? You probably won't see 30 times, yeah.
Okay. And now, and the answer to my second question is,
Yeah.
why not just make every proc natively compiled? But I guess the answer is,
Well,
it has to be in memory tables, right?
There are optimizations that we can do in code because we know the thing is in memory. Right? There are whole pieces of code we can throw out that it's not really easy to do if you have to maintain semantics, because the in-memory stuff is complete acid, right? So we have to be able to do that while you're doing an I/O and EOS is interrupting you, and so there's certain things that in-memory enables.
And then a follow-up question to the gentleman's temporal. So the schema is locked.
Right.
As of the system time for the actual temporal, are we able to potentially control that when that data is inserted, not necessarily be the system time of that insert, but
Application time.
a user-specified
Right.
input?
So the ANSI 2011 standard had the two type of time, system time and application time. What you were described is application time.
Okay.
It's not in this version. We're working on that.
Okay.
So we're going to have faster release after 2016. So hopefully it'll show up fairly
so
soon.
with 2016 temporal is at
Only
the
system
moment
time.
of change.
Yeah,
right?
only system time. Yeah,
okay.
triggered by the insert. Yeah.
Awesome. Okay, thank you.
Okay, sure.
Question related to always on. We have experienced, at least in our use, slight delay in the read-only replica. Is there an improvement in how fast the read replica is in sync with read-write node?
Yeah, basically, if you're running synchronous or asynchronous, what we've done is we've improved the channel. So the replication channel now is compressed, and we've cut out a lot of CPU consumption on that path. So it's able to keep up. So let's say you're running a database on Fusion IO, where you can do massive transaction rate, we can still replicate that.
Right, you will still see the slight delay because we synchronize the logs, right? It still have to be finished the redo before you can query those data pages. You're still going to see slight delay, but if your hardware is really fast, everything, and you have enough power on the secondary, it should be barely noticeable.
Is there any plan to add a syntax where we can confirm that all the replicas are in sync before the call is committed? Like,
well, how, right?
So-
Waiting for secondary to sync.
So the commit is only
I don't think
returned.
it's desired.
The commit is only returned when it's hardened, but not necessarily applied to the table. So you are safe from an HA perspective.
Yeah. Thank you.
I have a question about the JSON, namely an indexing. When I'm querying against, can I query against the property of the JSON? Or is it just, you mentioned it's just a varchar, I have to use a like statement or something.
No, you can query, but so we don't have index on top. You can do search equal to. There's no actual index other than you can add a compute column on that. Yeah.
And as far as the compatibility, you mentioned that first you code for the cloud and then the on-premises. So if I do have a SQL 2014 database that's currently running on an Azure VM, there should be no problem putting it in as Azure database.
Yeah. Unless you're doing things which require you to have access to the operating system, or you're touching files and things like that, which is not available in PaaS service.
Understood. Thank
All
you.
right.
Thanks.
We'll take one more question if there is, and then we'll call it quits.
All right. Thanks, everyone.
Thank
Thanks
you.
for sticking with us so late. Yeah.